Hello friends, myself Akash Reddy from Sri Venkateshwara College of CACD AI department. Today's topic is support vector machines, shortly known as SVM. Topics are introduction, how does it work, SVM parameters, advantages, disadvantages, applications, variants. At the last we have is a conclusion. At the first we have introduction. It is a powerful machine learning language used for both classification and the regression task. It is used mostly for the classification problems such as text classification, image classification, bioinformatics. In SVM algorithm, we plot each data item as a point in an n-dimension space where n is the number of features you have with the value of each feature being a value of particular coordinate. Then we perform a classification by finding an optimal hyperplane that differentiates the two classes very well. It is shown very well in the diagram. How does it work? Next we have SVM is a bilinear classifier that separates data into two classes by finding a hyperplane that maximizes the margin between two classes. The margin is the distance between the hyperplane and the closest data points from each classes. SVM can also handle nonlinear separable data by transferring the data into a higher dimension spaces. Identify the regular hyperplane. Here we have is the three planes ABC. It is shown in the figure also, where ABC are randomly placed in the diagram. Now identify the right hyperplane to classify stars and the circles. Select the hyperplane which segregates two classes better. In this scenario, hyperplane B has exactly performed the job. Identify the right hyperplane, scenario 2. Here we have three hyperplanes A, B, C and all segregate the classes well. Now we can identify the right hyperplane. Here maximizing the distance between the nearest data points at the classes and the hyperplane will help us to decide the right hyperplane. The distance is called the margin. In the above image we can see that A, B, C are placed in a particular order and we can see that stars are in a particular plane and circles are in a particular plane. Here you can see that margin from a hyperplane C is high compared to both A and B, hence we name the right hyperplane as C. Another lightning reason for selecting the hyperplane with a higher margin is robustness. If we select a hyperplane having a low margin, then a margin high chance of misclassification, where stars in the below image stars are getting connected to a plane B and C and circles are connected to the plane A. In the scenario below we can't have a linear hyperplane between the two classes, so how does SVM classifies these two classes? Till now we have only looked into linear hyperplane. SVM can solve the problem easily. It solves this problem by introducing addition feature. We can add a new feature that is equals to x square plus y square. Let's plot the data as on axis x and y axis, y and z axis, sorry. In this plot, points to be considered are all the values of z will be always be positive because that is a squared value of squared sum of both x and y. In the original plot, a red circle appears close to the original plot of the x and y axis, leading to the lower value of the z. The star is the relative away from the original result due to the higher value of the z.
In machine learning, one of the most fundamental tasks is when you have a bunch of objects that you want to classify into two categories or more. Is this picture of a dog or a cat? Is this dog going up or down? SVMs or support vector machines are some of the simplest and arguably the most elegant methods for classification. Each object you want to classify is represented as a point in an n-dimensional space. and the coordinates of this point are usually called features. SVMs perform the classification task by drawing a hyperplane, that is, a line in 2D or a plane in 3D, in such a way that all points of one category are on one side of the hyperplane and all points of the other category are on the other side. And while there could be multiple such hyperplanes, SVM tries to find the one that best separates the two categories, in the sense that it maximizes the distance to points in either category. This distance is called the margin, and the points that fall exactly on the margin are called the supporting vectors. To find this hyperplane in the first place, SVM requires a training set, or a set of points that are already labeled with the correct category. This is why SVM is said to be a supervised learning algorithm. In the background, SVM solves a convex optimization problem that maximizes this margin, and where the constraints say that points of each category should be on the correct side of the hyperplane. Using SVM can be as simple as loading a Python library, preparing your training data, feeding it to the fit function, and calling predict to assign the correct category to a new object.
Next we have is the SVM parameter. C is a regulation parameter that controls the trade-off between maximizing the margin and minimizing the classification error. Gamma is the parameter that controls the shape of an discussion boundary. High gamma value lead to a more complex discussion boundaries. Kernel function is a function that transfers the input data into a higher dimension spaces. Common kernel function includes linear polynomial and a radial Bayesian function, shortly known as RBF. Next, next we have is the advantages of a SVM. First we have is the advantages. SVM can handle high dimensional data and large data sets efficiently. SVM is robust to overfitting due to its ability to control the complexity of a discussion. Decisional boundary can handle non-linear sparable data by using kernel function. And disadvantages are sensitive to choose a kernel function and its parameters, can be computationally expensive for a large dataset, and a complex kernel function doesn't provide a probabilistic output which may be necessary for certain application. Next we have is the application of SVM. Image classification. SVM has been used to classify images based on their content, such as detection object in the image. Text classification. SVM has been used to classify text bound documents into a different categories, such as the spam filter or segment analysis. Bioinformatic. SVM has used to classify gene based on the expression pattern or to predict a protein interactions. Next we have is the variants of SVM. One class SVM support vector regression, shortly known as SVR. Multi-class SVM. At first we have is the one class SVM used for anomaly detection by finding a hyperplane that encloses a single class of a data points. Support vector regression used for regression tasks by finding a hyperplane that maximizes the distance between the predictive values and the actual values. And the last we have is the multi-class used for multi-class classification by constructing a multi-hyperplanes to separate different classes. The last we have is the conclusion. SVM is a powerful machine learning algorithm that can handle high dimension data and a large data set efficiently. SVM can handle nonlinear sparable data by using a kernel function. SVM has a variety of application in fields such as image classification, text classification, and bioinformatics. So, thank you.